Thank you for joining us. You are watching a career success video from Computer Coach. Computer Coach is a Tampa-based computer training center specializing in helping IT and business professionals add on the skills they need to reach their desired career goals. If you are job searching, in transition, or are looking for guidance, please feel free to reach out to us at www.computercoach.com. Now, let's get started.
Welcome, everyone. And as Cassandra said, happy Friday. Thank you so much for joining us. I am Danielle Ori. I'm the Director of Career Services at Computer Coach. I'm also joined by Cassandra Perez, who's the Director of Career Strategy at Computer Coach. And for those of you who may not be familiar with Computer Coach, we are a Tampa, Florida-based training center that specializes in upskilling, tech boot camps, continuing education for IT professionals, seasoned IT professionals, business professionals, and those looking to break into tech. If you're in transition, I also want to let you know that, if you're looking for guidance or anything like that, please reach out to us. Computer Coach has free career strategy sessions to explore a wide range of training opportunities. So we'll put that link in the chat at some point. And speaking of putting something in the chat, I'd like everyone to make sure that they put their LinkedIn URL in the chat to make sure we're connecting with one another and really enriching this experience after we've learned from our wonderful guest speaker today, who is Sam Kasimalla. I'm really excited to welcome him today. And thank you all so much for joining us. And so without further ado, I would like to go ahead and kick it over to Sam, but I also want to remind you to use the chat throughout the presentation. It's going to be really interactive, but if you have a specific question, it might be great to just go ahead and use the Q&A feature so that we don't have to scroll through all of the chat sessions. All right, then. Sam, over to you. Welcome.
Awesome. Thank you so much for this, Danielle and Computer Coach. My name is Sam Kasimalla. I currently am working with a company called JFrog, and I've been doing IT stuff for about 14 years now. My primary skills are DevSecOps. I've been a full stack developer for most of my career on Angular, Java, Python. I was ex-FANG, meaning I was an ex-Amazon engineer working on AWS and implementing it for our public sector customers. I started off my career on Wall Street as a risk analyst. I was with a major financial company, like one of the biggest, the top 3 banks in the US for about 6 years, worked for a big 4 company, and also founded a startup a couple of years ago and had a successful exit from it. Yeah, I also organized the Tampa Java group, the AWS user group, and the AI user group with a combined membership of about 55,000 people now. So yeah, I'm a hardcore developer, so I'm a hands-on person. So today's topic is about demystifying cloud. So before I even start, I'd like to just say that I want to make this as interactive as possible because this is a pretty entry-level topic, and I'm assuming a lot of our members and attendees today may not have much experience in IT. So please post your questions, or I'll probably ask questions. It may not be feasible for you to come on voice, but if I'm monitoring, I'm looking at the chat. So if you can please put your answers in there, that would be awesome. So to start with, do you have any experience in IT? Would you please put your answer in the chat box or the Zoom chat? Or are you from IT or from non-IT? Okay, is no experience. Thank you, Christina. Any more answers, please? That way I would know how much to deep dive into any of the technical topics versus to keep it at a 20,000 foot view. That's the reason I'm asking this. Awesome. Technology sales. That's awesome. Thank you. Trying to break into tech. Awesome. Yeah, tech definitely pays really well. I think everybody knows that. Awesome. No experience in IT. Thank you for that. Awesome. PMP certification. That's a really great way to break into tech. Yep. Bootcamp, grad IT my whole life. Yeah, that's awesome. Bootcamp is a really popular thing these days. Hearing about people having a lot of success with bootcamps and breaking into tech. Awesome. Okay. Thank you. Thank you for all the answers. So what is cloud? I mean, this question is one of the basic things, right? Cloud is a generic word, like literally the word cloud is like those three types of clouds that are on top of us, which hold moisture, give us rain. But cloud in computer science basically comes down to somebody else's computer. So we'll get into the technical details. Actually here, cloud refers to computing services, which are servers, storage, databases, networking, software, analytics, intelligence, and others over the internet. So in the crux of it, if I have to explain this to my kids, I would say cloud is just using somebody else's computer. So instead of using my own laptop, I'll be connecting to somebody else's laptop or server. A server is basically a computer sitting in some dark, cold warehouse somewhere in Virginia. Most of the major data centers are in Virginia. So connecting to somebody's server using SSH or some kind of remote desktop protocol. So if you've used these softwares like AnyDesk, we use this screen sharing where you can connect to somebody else's computer. Tech support might have done that. There are other ways to connect to computers. One of the popular ways is called SSH, secure shell. So basically it's a way to connect to somebody's computer at the crux of it. And cloud computing is also like renting a car. So instead of buying your own hardware and running it and maintaining and putting software on it and updating the software if there's any viruses or any vulnerabilities that are found, somebody else is going to do all of those things for you. So that's the simplest definitions of cloud. Cloud also has the offering of pay-per-use. So if anyone is from business background, you would have known that there's this thing called CapEx, which is capital expenditure. And then there's OpEx, which is operational expenditure for any business. So if you buy a car upfront by putting in cash, that's like CapEx, right? On day one, you're putting money out of your pocket. But if you lease a car and lease it for 3 years, you wouldn't put all the money upfront, but you'd be paying a little bit of amount every year or every month, which is like OpEx, meaning you won't have a lot of upfront costs, but you'll have operational or basically monthly expenditure that goes with your car. The same exact concept. So cloud, before cloud, people had to go order a lot of servers from these big companies like Deloitte or IBM, or there's many other companies like hardware providers. And they had to like get a warehouse, lease a warehouse, where they came and set up all the networking. And after the networking was set up, they had to hire engineers to install software on it, which we call as operating system, like Windows, Linux, or Mac OS, and then connect it to the outside world using one of the internet service providers. But with cloud, all of this is automated with a couple of clicks of buttons or sending out a couple of commands using a black screen, which we call the terminal. And we can fire up all that infrastructure, which usually took 6 to 9 months or even years to build out that infrastructure. So having talked a little bit about definitions, do you have any questions in what is cloud or why cloud? We are about to get into why cloud, but do you have any questions on what is cloud? So I want to share one more thing. Infrastructure, meaning anything that relates to IT, running IT, boils down to three main things. This is one of the core things that we need to understand. Anything else is built on top of this, like anything, writing software, Java, code, becoming a cloud expert, anything really builds on top of these three things. So infrastructure boils down to these three main things: networking, compute, and storage. So when I say networking, it's basically having a router or having a network, router, switches. There's various other network appliances and devices, but setting up something called as company level network, which is usually referred to as a VPN. In cloud providers call it VPC, virtual private cloud. VPN stands for virtual private network. And usually it uses a combination of LAN, WAN, or mostly LAN and few other network connectivity options between them. So basically running the wires, connecting it to a router, or having wireless connectivity to the servers. That part is called networking. And because of cloud providers having technology where they can take software and basically manifest that software through hardware, we can actually run some software commands and set up a LAN or set up a network within a few minutes. And then there is this thing called compute. So previously, back in the day, it was bare metal, meaning we literally got a computer, plugged it into the network, and installed the operating system directly on it. But as time went by, people got smart and they installed these things called hypervisors, where you could put in any virtual machine on that hardware and basically run any operating system. So that concept is called as VMs, which is also virtual machines. And then we have containers, which has been adopted largely since the last 5 to 7 or even 10 years, since Google came out with this thing called K8 or Kubernetes. If you have heard of Kubernetes, it's also called K8. So running these little virtual machines on top of virtual machines with a lot of control on how they can be deployed and how many instances or how many of those little servers can you spread across multiple data centers, and all those things can be configured by a simple text file. So that's the reason the adoption of Kubernetes is going at a crazy pace. Like everybody wants to use Kubernetes now in the infrastructure world. And then we have storage. So previously, if you have a laptop or if you have a computer at home, if you ever opened it, there's this little hard disk that basically attaches to your motherboard. So that hard disk, when attached directly to the motherboard of a computer, it's called direct storage. And then as evolution went by, people basically built a little network of hundreds or thousands of hard drives, which can be connected to a computer over network, like meaning over a LAN or local area network or any other network. So that kind of network where the hard disk is not literally attached directly, but it comes over a transport protocol is called network storage. There's iSCSI drives. There's a bunch of different technologies, NetApp and all the other companies that are built on network storage. And then there's object storage. So I think the object storage evolution started with the cloud providers. If you've ever heard of S3, it's a very popular storage system that was kind of released by Amazon. It's called Simple Storage Service, where you can actually, just like you connect to open up Zoom or Microsoft Office 365, or even connecting to Facebook, you can use web APIs to push objects to it, or basically save objects, just like you save it in OneDrive or Google Drive or any of these drives. So basically, it's like its own little service where the connection happens more at a higher levels, meaning at an application level or at a level where we call them the APIs. I'm trying to avoid words which may not make sense to non-IT folks, but it's basically the nearest thing that I can give. A simpler example would be something like a OneDrive or a Google Drive. So that's called object storage. So most infrastructure boils down to these three main categories. I know I took some time on this slide, but this is the base of any IT service. So, and this is probably the most fundamental things. If you understand this, it's very easy to build other stuff on top of this. Okay, having said this, do you have any questions so far before I move on to why do we need cloud? Okay, I see something in Q&A. Perfect. Okay, there's no questions. So I'll go ahead and continue. So why cloud? One of the best things that people used to share a lot, not anymore because things have changed over the last 10 years, is accessibility, meaning anywhere on the internet, you can access a cloud data center. Whereas in the past, when people had to access a data center, they needed to go to that location and actually plug in their computer to the network or wirelessly connect to the network, but they had to be on premise. So that was one of the limitations. Things changed now, but that was one of the original reasons why we said cloud is important. The second thing is cost savings. In my previous slide, I spoke a little bit about CapEx, which is capital expenditure, versus OpEx, which is operational expenditure, meaning buying a car upfront with cash versus leasing a car. So the same thing applies here. So because you're leasing it out, you don't have to front that money on day one. Building out a data center many years ago could easily cost over $1 million, even for smaller companies. So that would be a huge upfront cost for many companies. So cloud basically allows you to start with $100 or even less than that and get your own servers without having to build out the infrastructure. So that could contribute to cost savings. Then the security. So there's this thing called economies of scale. Meaning if you do something for one person, like if you are familiar with carpentry, if you want to build a table just for yourself, it might actually cost you $800 because you have to get all the paints, the wooden boards, spend your time, all that stuff. But when a company does it with a scale of thousands of tables, they could probably build it for less than $50. That concept is called economy of scale. So because cloud providers are so huge and they have thousands or even 10,000s or hundreds of thousands of customers. They have pretty much seen every single case of how security could be breached. So they basically take care, they have their own internal teams that learns from 10,000s of customers and builds all the security products into their cloud provider, or basically builds the security fences and defenses inside their systems, which would be super expensive if you had to build it for yourself. So that's security. And then there is disaster recovery. So once in a while it happens, if there's ever a flood or a natural disaster, or in some cases there was a shark bite, which actually, so before I say shark bite, there was this big cable that runs between US and Europe, and it goes under the Atlantic, a couple of miles deep. And I think it was a whale or some kind of marine animal that damaged that cable. And there was the internet connectivity between Europe and US was super sketchy and spotty during that time until that system was repaired. Again, I know there's other redundancies and other stuff, but that could be an example of a disaster. Or something like a natural disaster. A popular law firm here in Tampa, during one of the recent hurricanes, their data center got flooded. So all of their systems were out for more than 2 or 3 weeks. And all of the employees of that company couldn't even access their files or nothing. Nobody had to work, and that company or law firm had to take major losses. So cloud computing usually has data centers in various geographic places. And they do this thing called disaster recovery, meaning they maintain a copy of the data, or you can set up your infrastructure in a way you can maintain that copy of a data in a different data center. So if your main data center, which if it ever gets flooded, or if we are ever in a nuclear war, and if it directly takes a missile hit and gets destroyed, your IT services will not be affected. So that's called disaster recovery. And then flexibility. So the scalability. So in the past, if you had to buy a server, you had to go through this 6-month process where you order it, install the software, do this thing called requisition, do a lot of other stuff, install the server in your data center. But now you could just click a couple of buttons or send a couple of commands and increase the number of machines or computers that are inside your company's network. Cloud options, the control choices, the tool selection are a few other reasons of why cloud is so flexible. And then we have increased productivity because your infrastructure teams do not have to go through this whole process of buying. They can spend that time for other things. So Raven, I see your question. I'll come to it in a second. So the productivity of them could be increased a lot. The software updates are automatic, meaning you don't have to spend your time or your company, your engineers' time to actually do the patching. The cloud provider can do that for you. Competitiveness and increased collaboration, because you don't have to do all the grunt work. You can be more competitive, you can focus on your business, and you can also increase the collaboration between your different teams. Okay, so coming back to Raven's question, in case of disaster protection, you should store your resources in different zones or data centers. So yes, so I'll take the example of AWS. And in AWS, we have this thing called regions. US East one is a well-known region, Virginia data center. And then we have this thing called availability zones. So you can actually put your infrastructure in different availability zones, which are not the same data center, but which are still few miles apart, but within the same geographic area. Or if you want actual disaster recovery, you can put one in California, and you can sync the data between the East data center, the Virginia data center, and the one that's in California. We have a question from Core Francis. Do you see time when cloud computing will be a regular cost-effective resources for everyday home users? A lot of home users do that. I personally have a couple of instances running on the cloud that are doing a bunch of stuff for me, doing machine learning stuff. Like a few years ago, I did a project where back then Zigbee and Amazon Ring and all these things were not really out in the market. Ring was, but okay, let me explain what I mean. So I basically had sensors all around my house, like door open sensors, door close sensors that connected to my data, that connected to my camera systems. So all of this, to process it, I either had to run a laptop in my garage, or I could have run it in cloud. So I ran it in my garage, and then my kids were messing with it too much. So I actually ran this server on the cloud. So people are using it, and cloud, it's not even that expensive. If you run it for the whole month, the cheapest instance, you could run it for less than $20 a month. So that is already happening. Now, about a little bit about the market trends. So in the past, if you had to run software on your infrastructure, it was expensive. I won't mention the company name, but the world's most popular database system used to cost around $30,000 to $40,000 a processor. Meaning, if you have an 8-core computer, you would have paid like 100 to 200 grand just in licensing software a year. And people used to, and companies, one of the major expense for the companies to pay all this license costs. But now the cost of licenses are going down and people are not licensing software anymore. It's like a trend since 2000. This trend ends in 2020. I'm pretty sure it's gone down lower in 2023. And the cost of subscriptions are going up, meaning putting money upfront is going down and people paying a monthly rent or a lease kind of amount is going up. So everybody is doing this. And if everybody is buying Apple iPhone or whichever phone, there should be something good with it. And that's also contributing to the cloud growth, which is the market trends. So I'm planning to end this in the next 10-ish minutes. So from here, I'll probably start flying or going faster. But if you have any questions, please let me know. Yes. And I saw somebody mention the name of the database company. And yes, that's the company. I'm not mentioning the name, but I'm just confirming what they sent me on direct message. So this is a basic technology evolution that's been going on since the last few decades. Prior to 1980s, the IRS still uses mainframes. IBM was the biggest name in that space. IBM mainframes, the Z series, they're still popular. Some older, extremely old banks and even organizations like IRS still use them. In 1980s, we started having Unix machines, servers. And then I mentioned something about hypervisors, which is running virtual machines. That started picking up pace in 1990s. Companies like VMware basically democratized and gave the technology to general public. In 2000s, AWS was formed, Amazon Web Services, which was the first cloud provider. And the cloud revolution started. A lot of open source revolution started. Google and the big data revolution, not Kubernetes per se, but HDFS, Hadoop, they come from Google's paper on distributed networking. So cloud revolution started around 2000s. And in 2010, we had this newer technology on Docker, which is containerization, meaning virtual machine on top of a virtual machine. We had single page applications, which also revolutionized how we talk over web and the bandwidth required to download the pages, and also container management services like Kubernetes. In 2020 and next, actually, this slide, I built this about 3-4 years ago or even 5 years ago. And this prediction is still accurate. And I didn't even make much changes. 2020 and past 2020 is the age of AI. Quantum, if you would have seen the news, Google built one of the most powerful ever quantum computing. And some of the security organizations around the world are concerned about it, because something that would take 10 years to crack a password using a brute force attack would now take only a few minutes for a company with something like a quantum computer. And low code platforms where you can just drag and drop. MuleSoft was recently acquired by, not recently, but acquired the last couple of years by Salesforce. So low code platforms, automatic AI-based code generation services are picking up pace. So this is a little bit of evolution on how we got here. And then I just want to talk about top 10 cloud providers. Amazon Web Services is the number one name. They take the market share like crazy. Like they are way, way, way ahead of any other competition. And then Microsoft Azure, the same Microsoft that gives us Windows. They started their own cloud provider. They are a cloud provider, and Google Cloud. So these are the primary major ones in the US. We have Alibaba, Salesforce, Dell, IBM, DigitalOcean, but compared to the adoption by the top three, these are smaller than the top three cloud providers. I think there's a slide on which one is the most used, but before I get there, let me talk a little bit. So AWS has been around since 12-ish years. Again, this is an older slide, so these numbers may not be fully accurate, but this was the oldest, as I mentioned. It has all these little itty-bitty features. It has too many options. Like if you go to AWS and log into console, it has 150 services. And I work for AWS, even I may not know every single service that AWS has. And then there's Microsoft, but it has its own things because it's slightly newer than AWS. And the same thing with Google Cloud. It has a lot of open source support and portability. One of the reasons I personally like it. But again, it really depends on why would you have to use this, or why would you want to use cloud. It basically comes down to why do you want to use cloud before or then choosing a cloud provider. And levels of cloud. This is an important slide. when you have your own on-premises data center or infrastructure, you basically manage the applications, the data, the runtime, the middleware. Some of these words may not make sense, virtualization and middleware, but you basically have to take care of all of them, like the entire stack, if you are familiar with the OSI stack. But in case of infrastructure as a service, which the cloud provider start at, this is one of the levels where they start at. You only take care of applications, data, runtime, middleware, and operating system. The rest of it is taken care of by the cloud provider. And if you do something like a platform as a service, you only manage these things. For example, there is this service called RDS, which is database as a service, meaning you only put your data in there, you take care of the applications that connect to the data, but rest of them are taken care of by the application. And then there's this thing called software as a service, where you basically, the application takes care of everything. And one simple example of this would be Microsoft Office 365, or even your Google Sheets or Google Docs, right? You don't really have to install Microsoft Office on any of those servers and a SharePoint or any of those tools. You don't have to worry about none of them. You just log in, you use them, and they take care of where they store the data, your IT infrastructure, and everything else is taken care of either Google or Microsoft. So these are the different levels of cloud. And then this is another important slide where every company provides similar services. I don't want to say the same because there are some nuances and differences, but there are the naming or the way they call them are different. So before I start talking about it, do you have any questions on this previous slide? Because this is a lot to digest, especially at this pace. Okay, I don't see any questions in chat or Q&A, so I'm going ahead. So platform as a service, you can ignore this for now because it's basically if you want to get a database and a web server together within a single few clicks. There's the service called Elastic Beanstalk in AWS, Cloud Services in Microsoft Azure, and App Engine in GCP, which is Google Cloud Platform. For serverless computing, again, I'll talk a little bit about serverless in the next slide. There's the services called Lambda, Azure services called Azure Functions, Google's services called Cloud Functions. Docker management, AWS services called ECS. This is easier naming. I kind of like Microsoft Azure naming because it's easier to understand. Because if I see S3, unless I know what S3 is, I really wouldn't understand. But if I see Azure's name, it's easier for me to say, okay, what it means. Okay, it's block storage or object storage or cloud storage. Glacier, I wouldn't know what Glacier is, but if here it basically says archive storage, meaning putting storage in cheaper storage, meaning there's different types of storage. The RAM that you use is way more expensive. And even in the RAM, there are these classifications called L1 storage, L2 storage, L3 storage. L1 is super expensive because it runs on a different type of electronic technology. L2 is cheaper, but it's bigger. L3 is way cheaper, but it's bigger. And then we have SSD, which is solid state devices. Those are expensive than hard disk, but they are also smaller than hard disk, or the cost per gigabyte or cost per storage would be higher as we go up the ladder of technology. So the cheapest type of technology is tape storage. I mean, it's not too different from hard disk storages, but if you want to store something for real cheap, that means you store it there for 10 years and it would only cost you like $20. So that kind of storage is also supported by or is available with cloud providers, and that's called archive storage or Glacier in case of AWS. Or file storage, which is slightly expensive than archive storage. It's called EFS, Elastic File System. In Azure world, it's called Azure Files. And in VM world, it's either ZFS or Aware. Global content delivery. So if you have a website server running in the US, but you have users all across the world in Russia, Europe, Philippines, India, and all those countries, you might want to use something like a global content distribution where it leaves this little edge nodes, as they call it, meaning this little web servers that sit in that specific geographic location, but take data from the primary server. It's called a delivery network. I like the naming that Microsoft Azure does. It's way more meaningful to understand, especially for beginners. And then if somebody knows what is data warehousing, all the previous, so any database usually has this thing called transactions, but the transactions are pretty for the previous n days or n years only, or n months, or previous 5-6 months. After the first few months, the transactions are moved into a different type of thing called data warehouse. And Amazon's data warehouse is called Redshift. Azure's warehouse is called SQL Warehouse, and Google's cloud platform is BigQuery.
You do have two questions. Just wanted to bring your attention to that. One is, what are examples of a platform as a service? And then you have a participant with their hand raised.
Sure. I don't see that on my screen, but please. So one example is RDS. So I wish I had another slide for this, but so there is this service called RDS on AWS, which is a relational database service. If you're aware of SQL or Oracle database or MySQL or Postgres, the cloud provider takes care of everything below the data and the application level. So you actually put the data, but you do not worry about installing a Postgres. In a typical olden on-premise data center, if you have to run a database like Postgres or Oracle or MySQL, you would have to download those binaries or those executables, log into the servers, install them, and every time there is a patch or a vulnerability patch that is released, you'll have to go back and patch it or run some commands and update the database. Whereas in a platform as a service, like something Amazon gives us, like RDS, you don't have to do any of those, all of that patching. I mean, you can choose the versions, but patching and all the other lower level things, or getting the servers, installing, and all of them are taken care of by the cloud provider, in this case, Amazon. So RDS is a simple example of platform as a service. Hope that makes sense. Okay. About the hand raised, I can't see it, but if you can please put your question in there, I can read it out for everybody and answer it. Okay. So I think I'm almost at the end of time, but I just want to cover traditional serverless, 2 more slides, and that's about it. Serverless is the next level of cloud. So it's like the cloud of clouds, meaning in cloud, you have to maintain some kind of infrastructure. In serverless, you don't care about infrastructure. You just write your code if you're a developer and just say AWS has this thing called Lambda. You don't have to worry about running the servers, the backend, any of those. You just say, okay, I'm copy pasting or pushing my code to this, and this is run by AWS Lambda or Cloud Functions or Azure Functions. So serverless is slightly misleading term. So yes, there is a server, but there is no server for you to manage. So yes, it still runs on servers. As this meme says, serverless is actually servers, but you don't manage those servers. So it's like, basically, I like to say the cloud of clouds, right? So you just write your code, and the servers are maintained by cloud providers. That's this concept of serverless. Getting started with AWS, you can go to aws.amazon.com, and free tier, there's a bunch of things, you can read it on that screen. Getting started with Azure, you can go to azure.microsoft.com and click on start for free. Getting started with Google Cloud, you can go to cloud.google.com and click on get started for free and go from there. Quick thing about certifications, we're at time, but you can have foundational certification if you want to learn AWS. This is pretty easy. Anybody can do it within a couple of weeks. It's called Cloud Practitioner. If you want to build your expertise, there's associate level certifications, there's professional level certifications, and there are specialty certifications. Similarly, with Azure, there is this thing called a similar fundamentals AZ900. If I'm not mistaken, Computer Coach also provides training. I'm not sure, but I think they do. Daniel, please correct me if I'm wrong. And there are associate level certifications, and there are expert level certifications. Similarly, with Google, we have foundational, which is called Google Cloud Leader, a 2-week basic foundational certification. Then they have associate, and there are professional. So yes, that kind of concludes our presentation. We'll have some questions time now. I don't know how long I have. And Daniel, please feel free to interject if I'm taking too long. This is my LinkedIn. You can scan it from your phone and click on connect. And yeah, let's spend some time on questions.
To learn more about our training programs, classes, and what sets us apart, please visit our website at www.computercoach.com.